Okay, I think we are set up and we are simulcasting here. So, Veronica, you want to get started? We can go ahead.
Yes. Oh wow. Kishore prepped all the questions. Kishore prepared 7 questions for us already for the Quai and Qi conversions. So let's start with the first one. How will the exchange rate for Qi to Quai and Quai to Qi be calculated? Let's start with just one question.
Um, yeah. So the idea with the conversion controller is based off two concepts. The first concept is that the miners will not create chi if the market price of chi is not higher than their sort of production cost. Um, the second assumption is that uh, the controller basically targets a market neutral preference. Sorry, hold on one second. I'm getting a little bit of feedback here. Okay, we'll give that a try. Um, sorry. So the second thing that the controller is doing is basically trying to make the market neutral to the rate that is offered. So what ends up happening is the sort of exchange rate between Quai and Qi is adjusted until the minor choices as well as the speculator choices of sort of converting from Quai to Qi or Qi to Quai are equivalent. At that point in time, you would say that the market is neutral to the offered price, which means the offered price is reflective of the market price. So, volume will play a role per Kishore's question. So there's a thing that we're adding to the controller, which effectively looks at the volume sort of over time of the sample. And when you convert, you effectively get slip on your convert depending on sort of how much volume it is relative to the recent historic volume. So the controller sort of can push up or down volume, but to move sort of like what it thinks, it's kind of giving you a discount rate. So if say the average volume was, I don't know, 100,000 chi or something over the last sample period, and you come in with like a million, maybe you'll get like a 20% slip trying to do that, so to speak.
Okay, yeah, that makes sense. That actually answers the following questions: whether the volume of conversions play any role in the exchange rate, and whether the volume data should help in SnapSync as well.
The volume data in SnapSync. I don't know how that the volume data is related to SnapSync. Um, but yeah, I think we've covered everything in the first question.
Yeah, so wouldn't Qi to Quai and Quai to Qi exchange rate be the inverse of each other?
Roughly speaking, that's correct, but depending again on volume, um, that's not true. And then the other thing that you have to consider here too is that there's a lockup during the conversion. So when you do conversions, you're under the sort of the minimum unlock for Coinbases, which is 2 weeks. So there's a time value to conversions. So you can't think of the conversion rate as being equivalent.
Yeah, okay, that makes sense. What is the smallest unit of Qi? Is it cheats? And is that of Quai? Is it its?
Yes, that's right. So Ethereum has, I guess, Way for um, its smallest unit. We came up with its for Quai and chits for Chi. So an it is analogous to a Way, 10 to the minus 18, and a chit is 10 to the minus 3.
Okay. Is there any like reasoning behind this naming?
Uh, not like a ton of reasoning.
Yeah, okay. I mean, the names are nice. I'm just like wondering what if, because like Quai and Chi have the very, I mean, meaningful history of why they were named this way. So
yeah. So I mean, a chit um does have a meaning, right? It's I believe an English word for like a token. Um, so that's kind of that. It's the issue because 10 to the minus 18th is used in EVM land. Um, the name chosen needs to be sort of compatible with SI prefixing. So with it, because it's starts with a vowel, like you can think of like mit, git, etc.
that makes sense. So what now talking about the base fees. So Quai base fee will be in units of way, whereas Chi base fee will be in the units of cheats. And one cheat equals one. I mean, we just talked about the 10 to the minus 18 and just how many like the cheats instead of
Yeah,
every
so
chi.
so basically a
Mm.
thousand chits would be a chi, and 10 to the 18 its would be a quai.
Yeah, okay. I think that is a good answer for this question as well. What is a chi transaction fee doesn't exist in the pool? So, what if the chi transaction fee doesn't exist in the pool? We ignore that transaction or calculate the fee and include that transaction.
So with chi, the fee is basically the difference between the inputs and the outputs. So if you don't have a fee or it's not sufficient, then the transaction shouldn't get picked up in the pool and it won't process.
Sensible. Can we get the supply growth of the Quai and Chi tokens? And do they follow a logistic growth pattern? Do like
Yeah.
both
So
examples?
so quai is emitted proportional to the logarithm of difficulty, and chi is emitted proportional to the difficulty. There is a factor that the controller adjusts, which is there's like k value that's associated with the quai emissions, which basically sort of establishes an exchange rate between quai and chi. The amount of quai and chi in the world is going to be an outcome of hash rate growth as well as preference selection of people over time.
Mm, okay. And now let's talk about conversions a bit more, speaking of them. The full conversion fee, is it included in the block ETX gas limit?
Um, yeah, so there's like two parts of it. Basically, you have like the fee to process the transaction, and then maybe he's referring to sort of like the fee that's on slip. That's just like a rate that's taken, so you sort of get like an inferior rate as your volume goes up. So that isn't sort of a fee. That's just you get a different priced rate.
Yeah. Uh, we have a bunch more questions actually to go through. And Crypto Lucas is asking about the relationship between chi and energy costs. Since chi is closely linked to the costs of mining, which largely consist of energy expenses, would it be beneficial for miners located in countries with lower energy costs? For instance, if the majority of miners operate in the US and I'm mining in Vietnam, would the price dynamics of chi favor me if the energy costs in the US are substantially higher than in Vietnam?
Yeah,
That's a
I
good
mean,
question.
if you look
Mhm.
at mining and mining hash rate, right, it tends to the lowest cost regions. We would expect the same thing to sort of play out here, and miners who can, produce at lower costs are going to make higher profit. So at some point, depending on what your business model is and profile is, if you don't have access to low enough energy costs, you probably won't be mining Quai or Chi.
Mm-hmm. Yeah, that makes sense. Just like with any other mining, here it also applies. And also, then we're coming up to the question about the energy from the solar panels. So, Cryptolocus read an article about households in Europe building their fences with solar panels, and the cost of solar panels in general is decreasing. Do you think it is a good investment to use solar panels to power GPUs for Qi mining, especially in Vietnam? Or I could add myself Texas, which is close to China, potentially making solar panels even cheaper due to proximity.
Yeah, I mean, I can't speak specifically to the dynamics in Vietnam, but I think having low cost renewable sources to do mining is probably a good way to go about it. One of the reasons you're going to get lower cost too on solar panels is because your production isn't guaranteed. And if you're sort of okay with that trade off profile, which many miners are because they can get very low price renewable energy that way, it's potentially a very profitable business.
That makes sense. Actually, one of the questions about the other recent QI features that we started talking about, the work shares. So they, um, what do similar miners mean in work share who manage slice nodes? So, like, what is the management of the work shares with slice nodes? I guess, yeah.
Do similar miners mean in a work shares? I'm not fully getting the question. Maybe he can clarify a little bit more, but I'll just briefly talk about work shares. Um,
Hmm.
so in work shares, if anyone's ever run a pool or mined into a pool, the way that you sort of get rewarded for mining into a pool is you mine blocks that are sort of given to you by the pool, um, and then when your miner sort of hits a threshold that isn't necessarily a block threshold, but is some threshold of zeros, you sort of return what's called a share to the pool. And the pool sort of counts up these shares, normalizes sort of those shares to understand what hash rate you're sort of statistically contributing to the network. And then when somebody in the system does eventually find a block, they distribute the reward sort of proportional to the contributed hash rate as measured by the shares. Uh, Now, in Quai, we've introduced this concept of work shares. We do it for a multitude of reasons, but the specific impact on miners is that we're going to have anywhere from 10 to 50 work shares in a block. I think in testnet, we'll probably set it to 10. In mainnet, we may increase that number. But effectively, what that means is that instead of getting paid just the block reward, payments are actually divvied up amongst the work shares directly in the protocol. So if you're mining and you say you had one GPU that's going to pay you once a week, because of work shares, you're going to actually get paid potentially once or more per day because there's actually 10 payments going out per block on average. So it smooths out the sort of reward function for smaller miners, which makes it so that they're less encouraged to operate in a pool. It's effectively like
Hmm.
a protocol endogenous pool system. Now, there's other things that workshares do for us. I'll just kind of mention them, um, and we can circle back if people want to. But effectively, workshares allow us to efficiently propagate transactions through the network in a DDoS protected way. We do that by letting miners sort of reference their transaction pool into the workshares, and that's how the transactions propagate through the network. They also allow us to achieve what we call concentration. So if you think about proof of work as a sampling mechanism of a physical process, i.e., mining in the world, and the miners are voting on the tip of the system or the current state, the work shares allow us to get a higher number of samples in a smaller amount of time, which allows us to reduce uncertainty in the measurement, thus accelerating what we would think of as statistical finalization or concentration. Um, there's one more thing that they do for us. Shoot, can't remember right now, but if anyone has questions on it, we can talk about it more.
I think it was a good introduction, and just the whole explanation of the endogenous place of work shares and QI is somewhat along the lines what he was asking. But
There's one more. There's like six things actually. I'll just throw in one more because I thought of it. The other thing that it does is it actually creates a sub currency in the system, which is hash. Really, chi
Mhm.
is like hash currency in some ways. But there's still sort of like a de minimis sort of economic level where it makes sense to like operate in chi because you have shares. You know, let's say when we like deploy Nepo POWs, um, initially nodes will probably just some number of nodes will just run RPCs for fun. But as sort of that becomes more expensive, one of the ways they could do it is actually make people sort of pay them per query in share, which they can use to sort of submit just sort of like it's like a sub pool, so to speak. Um, but by having that sort of in the system, it makes it very easy for people to set up these like sub pool things that then can like take very, very small micropayments as sort of like another abstraction of a sub pool below that. So like very specifically, the idea would be you run an RPC, you advertise a rate that says like I will give you a sort of response for this amount of hash. The person responds to you with the hash, and then like you give them the response. So then they've like conducted a sort of completely off chain sort of like micropayment, which also is only really feasible for sort of small providers with this like work share based concept.
Mhm. I think Nipa Paus, we could talk a lot, like have a separate AMA for them as well. Again, we already had a university call if anybody is interested, but they just need more exploration. They're like cool enough, they deserve it. Anyways, so I think that's a great question that's Matrix is asking. So can you share some insight on the privacy aspect of Chi and just UTXOs, I guess, in general?
Yeah. So one of the things that we've looked at. I mean, we're trying to really solve like all the problems with crypto because we actually want crypto to be usable as a monetary system. But one of the problems that we see is that you can't have capitalistic commerce conducted on a completely transparent and open ledger. So, Bitcoin is completely see through to anybody who's looking. Ethereum largely is as well. Certainly, if you're not sort of using now banned systems which cannot be named. So the issue then is you need something that has cash-like properties. And you need this just to conduct commerce. So if you're in a competitive business, you're a competitive provider, if you're Chipotle, and Freebirds is across the street, right? And you're selling burritos. If I'm sort of getting paid in ether, then like everybody knows what price I'm paying on a given day, how many customers I'm getting, what my revenue is, what I'm paying to my suppliers, and everyone's gonna be conducting real time competitive analytics, which is make it very hard to run a business. So the idea being is we need some degree of privacy just to be able to make these systems economically useful. And what we think that is what I would consider to be cash-like properties or cash-like privacy. So if we walk into Chipotle and I spend a $20 bill, and I get $5 back, Freebirds doesn't know about that unless Chipotle wants to tell them about that. But obviously, Chipotle wouldn't do that. So we need a system that makes the transactions in Chi look a lot like cash-based transactions in the real world. Now, the way that we accomplish that is through really a couple things. The first is Chi is based off a UTXO ledger rather than an account system, and the UTXO units are fixed denomination. So just doing those two things, coupled with enforcing non-address reuse, at least per block, makes it so that everything in Chi will start to look very cash-like. There's a few other adders to it. They're a little bit complicated, but just having a very large set that has, a large number of entries in a small number of sets will give you cache-like properties.
Building the cash system, finally. That's a good question. I think everybody is wondering. After the Golden Age testnet is successful, will it still continue to the Silicon Age testnet or directly mainnet?
If everything goes well with Golden Age, we don't plan to do the Silicon Age. If we have issues that are unforeseen and we need to do another one, we'll do another one. But we're hoping we can avoid it.
Yes, let's mine as much as possible to check. So Kishore is asking, we check Genesis hash by hash and not by number, right? So the number filter will be used once we expand above Cypress 1. Also, can the Genesis block have any ETXs?
So the number filter will be used once we expand above Cypress 1. Yeah, so the Genesis block won't have ETXs. We do check the Genesis hash by hash, and actually for the expansions, there aren't Genesis hash. There isn't a Genesis hash. There's Genesis hashes. It's actually like a set, because when you do an expansion, that expansion will have a new Genesis hash. So there's like Genesi hashes. Yeah, so you can't really filter by number ideally, and we've actually recently gone through the code base and make sure that like we are doing a referencing by number, and then it's like only by hashes. But I think that answers the question. Yeah.
I think so too. Also, then there is a question about key aggregation and signature aggregation. Is key aggregation better than signature aggregation?
I assume he's specifically referencing Musig.
Maybe the chi
Okay, yeah.
abstraction
Let me just like talk about Schnorr for a second. So basically, like what happens with a Schnorr signature is when you do signature verification, it's expensive. If we do like ECC signature verification, you have to do like many sort of multiplications that aren't free in terms of computation. So the challenge that arises with Qi is because it's a fixed denomination set, most of the time you're going to see transactions that have many inputs and many outputs. What Schnorr allows you to do is it's an additive signature scheme. So when I have, say, 10 inputs, I can sort of create one signature, but I'm doing it on the addition of all of sort of the public keys in the set. So from a verification standpoint, each time I add a new input, I'm only adding a single addition. And then once I add everything up in the number of inputs, I'm doing one multiplicative operation to check the signature at the end. So Schnorr is only marginally more expensive than like a normal check sig on an ECC curve, because you're just adding this like very marginal cost of doing it in addition. So that's what allows us to kind of make it efficient to use Qi, because we're allowing you to add up sort of your input signatures before the aggregate signatures checked.
Yeah. I feel like the more like I hear about the way Qi was working, the more I get like, oh wow. But I think it would be also a good place to maybe for others who are not as technical, if you walked us through like how a Qi transaction would happen.
So
If let's say
from a non-technical user's perspective, right? Qi looks like a Bitcoin wallet, right? So when you use Bitcoin, you have many inputs. You don't know about those inputs. Your wallet just presents to you an aggregate total, and then you just send money, and it figures out how to like take many of your UTXOs, put them together, and make a transaction that has one or more outputs. That's all behind the scenes. From the user's perspective, they're just like address amount, and then the wallet software kind of does the rest. You'll see the same thing happen here with Qi. So all of this is happening in the back end, and it's all doing this in service of creating these sort of cache-like properties. But from a user's perspective, you don't really notice any of this. You're just like address an amount. So from a user's perspective, but we have to do a lot on the engineering side and the back end to sort of make this like work. But ideally, if it's all working, the users never really see it. Kishore did have one other question, and he says, "Do we have a provision for partial aggregation?" Yeah, so that's actually from a library called mu-sig. So mu-sig has the ability to, instead of just doing a check on a set with one signature, you could actually input multiple signatures to check the inputs. So that is available in the system.
Mm-hmm. Another one that we shouldn't miss, can this aggregation of keys be used cross-chain, cross-input, sorry?
Uh, yeah, I mean, so you can use as many inputs as you want, right? From whatever set you want. So, um, yeah.
The reason he's asking is that because we cannot predict which UTXOs will be spent together.
Well, but a UTXO isn't spent. The out points are spent. So when you look at the definition of the, like, definitionally speaking, a UTXO destroys one or more inputs and creates one or more outputs, and we call those out points. And so an out point is an address plus an index.
Mm-hmm.
And so when I destroy a UTXO, I'm actually destroying an out point. I'm not destroying like the transaction hash. And the out points like are the UTXOs really. So you can spend out points from many different places.
Kishore says, thank you. It's all clear now. Yeah, I think there is also a good question for a more general audience. So one of the QUAI features is the market discovered gas limit through ongoing second price auctions. Can you clarify how this is going to happen? I guess the QI arbitrage.
Yeah, this is sorry, no, this is a different feature. I think you might not be familiar with it, Veronica. Uh, yeah, so basically, when you start digging into existing blockchains, there are very few things that are game theoretically viable or even economically considered. One thing that I've mentioned, at least with Workshare, is that I don't know if everybody realizes that it was underlying my response, but there's actually no incentive to propagate transactions in a system. Like, doesn't exist. So, and this was actually written up by Aviv Zohar. It's one of his early crypto papers. It's Red Balloon something or other. But basically, what I'm saying is, if I'm a Bitcoin miner, I would actually do better by not broadcasting anybody's transactions and only mining them into my block. The only reason I broadcast them is because there's what might be considered a bag holder incentive, which is if we don't broadcast blocks, we're going to lose, or sorry, broadcast transactions, we're going to lose liveliness in the system. So in the sort of medium to long term, I need to sort of altruistically do this in the short term because the value of the network would decrease if I don't. So that in of itself is a completely mal-designed incentive system. Workshares provide a mechanism that if the miners want to get paid, they also want to propagate transactions to each other. So we've like fixed that incentive. Another incentive that isn't designed correctly is the fees that are paid, or the gas price. Now the reason it wasn't able to really be designed correctly is because people couldn't really scale their gas limits. So basically, by the time this became important, you were kind of having sort of this very fixed supply of transaction throughput or gas, and the chain and the technology really couldn't sort of adapt to it. So sort of making sort of mal economic designs of the system is fine because like the system can't really accommodate an economic outcome. Right. So in Ethereum, that means like gas rates just precipitously go up when blocks fill, and you end up paying $100 to do an NFT transfer. where maybe a month earlier you're paying 20 cents, and that's kind of how like it manifests. But with our system, right, we can keep expanding the amount of gas that's offered in a shard, because we've made accommodations so that we can have higher throughput per shard. And then if we sort of run out of gas in a shard, we can make another shard automatically based off system performance, and it just happens. So from a user's perspective, there's always, in the system perspective, there's always the ability to sort of add more supply if demand is sufficient. And in that situation, you actually want to design a market mechanism that determines the gas price in a market efficient way. And there are a small subset of things that are known to be dominant strategy incentive compatible, or at least in Nash equilibrium within game theory. And if we're looking at how to fill a block, what you are doing is you are conducting an auction with multiple items. And the way to conduct that auction efficiently is through a second price auction. So or this is also potentially known as like an RDA for a multi-set auction. So, which is a reverse Dutch auction. So we know that these are like market mechanisms. So the way that sort of the worker works is it's trying to maximize its revenue. So it will fill a block. But the rule is the gas price, the lowest gas price that's included has to be given to all the things that are included in the block. That makes it this sort of RDA thing. So then the workers that are operating for the miners to try to propose blocks are going to try to fill the blocks to maximize their revenue, which is the point at which supplies match with demand, and you're maximizing aggregate economic surplus for the entire system, and you're creating a market outcome that is in Nash equilibrium. So those are sort of the design and the characteristics of the system. Any follow-ups on that? I know that was a little long-winded, but sorry.
Okay. So I think I don't see the follow-ups like at the right now. But they have some other questions which are kind of similar to what we have already answered before. Ego. I read I read somewhere that the cost of mining one BTC is about 300. It's over 300,000 in Ireland, while it is just above 1,000 in places like Iran. Considering that we are having a currency linked to the cost of mining, how do we reconcile this case like this? So I guess we can focus on the reconciliation part and how this works out.
Yeah, I mean, at the end of the day, if Iran could truly make BTC for $1,324 at volume, they would keep making it until the price of BTC sort of corrected down to $1,324. Obviously, they can't do that at volume. So, each one of these prices has to sort of be volume adjusted to understand what its contribution to the market is. In this particular scenario, what you would expect if you have rational actors is exactly 0 people would ever produce Bitcoin in Ireland, and everybody would trying to be producing as much Bitcoin as possible in Iran. And you would effectively find that the market rate would then match whatever the outcome is at volume that is the mean of the distribution. So you have to think about this on a volume basis. You have to think about this on a rational basis. When it comes to miners, we observe this behavior, right? So if you're mining, pretty much nobody in the world is mining at scale if they're paying more than 3.5 cents or 4 cents at this point per kilowatt. And the ones in Western Texas, right, they'll lock in at like 2.5, 2.6. So if you think about the most profitable miners and sort of the real rate going into the system, it's pretty consistent in terms of like what the number is relative to volume.
Mm-hmm. I think that makes sense. Um, we have some more questions from Gishore about the signatures and just like the follow up on the signatures. The Sure signature supports key tweaking in the way it is done in ECDSA or in any other way.
Um, I do not actually know the answer to that question.
We can
So
follow
hold
up
on. So
later.
if we have only the y coordinate belonging to a given public key, can we derive the x coordinate? Yes, it's a compressed key scheme. Is it only possible to derive y from x and not the other way around? I believe, yeah, well, let me think about that because it's symmetric, right? Is sort of how that works. So, as I understand the math, I think you could go x to y or y to x. Don't quote me on that. In terms of the key tweaking thing, I don't actually know what you're talking about.
The next question is one of the key QI features about the gas fees. AlphaMine says, I've been wondering how network traffic will impact fees, particularly for Qi versus QI.
Um, yeah, I mean they're competitive, right? So Qi and QUAI are paying in the same fee market, so to speak. Um, Now, if QUAI is effectively like paying a ton for ordering, there could be some delays in Qi because most Qi people won't sort of be paying the same fees that would be associated to get intra-block ordering that you might see happen with QUAI. But at the same point, like QUAI or Qi could also pay a higher fee to then compete. But if there's like an NFT mint, Qi might suffer some slowness for a few blocks in the shard where that mint is taking place. There's really nothing you can do about that because these are sort of competitive goods, right? You're selling gas, and gas sort of goes to Qi and QUAI.
Mm-hmm. He sure went on to discover our GitHub a bit more. In the issue number 2015, the create endpoint to propagate singleton transactions to a trusted mining pool. So the testing plan is node A to receive transactions, no miner connected, TX mining enabled. So then node B to receive minimally mined transactions from node A. What is the minimally mined transaction? That's what it's called sub work share? And this basically serve as get work to node A.
Okay. Right. So this is actually a pretty complicated question. So what we're doing is with work shares, we're creating an in-protocol system that creates an incentive for miners to have to propagate their shares, and in doing that, they're propagating transactions. What that means, though, is that the miners are sort of ingressing transactions at sort of the rate of hash that they represent in the network. Now, if we want to get sort of lively propagation, if we have say 20 shares, if you have say 5% of the hash rate within a block, you'll expect to produce a share. So you would be sort of a perfectly lively entry point for somebody submitting a transaction. The reason we have to do this in protocol is because once messages fly through the network, the only way that we can offer DDoS protection is through working objects that propagate, because it's the only thing that we can validate. So that is sort of the purpose of work shares. It's twofold. One, to create a DDoS sort of wrapper, and the second is to force miners to propagate transactions. Now, the problem from a UI UX perspective is you then are effectively having to get workers to pick up your transaction, or miners to pick up your transactions so that they can get into work shares and propagate. And so the miners themselves could just sort of run on their own, and if they have decent hash rate, they're going to be like a good sort of point of propagation. But let's say you're a small miner. There's a way that if you are willing to trust like other sets of small miners, you could effectively put together what isn't a working pool, but is a sort of transaction pool that is shared amongst those sets of miners so that you can sort of guarantee good propagation characteristics in terms of liveliness of propagation of transactions in the network, even though you're running like a small amount of hash. But to do that, any members in the transaction pool need to either have trust or a DDoS mechanism that is like being fixed in that pool. So if sort of I create a pool with people, and everyone's like, we're going to behave well and not sort of spam this pool, then like we're all fine. If someone misbehaves, maybe I'll have to like kick them out of my pooled set and we'll have to turn them off, or we have to have some sort of like flow control or ranking system, but that's independent of the protocol. So there's this like system that could be very simple, which is like there's just a couple people that have miners that get together and they like pool their hash rate. Again, well, they're pooling transactions, not hash rate, but they're pooling transactions to get liveliness, so they're a good ingress point. It could be very simple, and then you could actually make sort of all sorts of things on top of that if you want to, but that's sort of out of protocol management of DDoS on the ingress and propagation of transactions that then feeds into the in-protocol thing, which is propagation via workshare. So that little PR or issue is the mechanism by which will allow people to begin to create effectively shared transaction pools.
Okay, thank you for that. And Kishore has another question that is about the controller. Does the state limit adjust the block based on the controller? Adjust in the block.
Yeah, okay, so there's like a couple controllers in the system. So there's a gas controller, there's a state controller. And basically the state controller is controlling how much of the gas can be used for state. And it's sort of like running on like a moving average. So over time, if there's sort of more demand for state than gas, like it'll like slowly sort of rise to allow more state to be created per block. And then if it sort of the demand goes away, like it will fall. And the reason for that is just, again, sort of mitigating sort of attacks on state. Now, state also is priced, and it's priced sort of relative to that limit. So you're creating a like a protocol constraint that causes a market to create, that the market ideally will make any sort of like state bloating attacks expensive, is kind of like the point.
Mm-hmm. Okay, I think that is answering the question. Okay, and the next question is from Crypto Lucas about the liquid mining tokens. Are they going to be tested in the Golden Age testnet, including marketplaces for selling and buying liquid mining tokens after miners issue them, or lending markets with the liquid mining tokens as collateral?
Yeah, so we have a partner. Do you remember the name of them, Veronica? It's a portmanteau of Quai. I'm the tech guy. That we have a partner that has spec'd out building the contracts and the markets associated with liquid mining tokens. Sort of our hope would be that they can get that developed and deployed in Golden Age. But again, it's like a partner, so I can't speak specifically on what will happen. But yeah, our hope is maybe in the middle of Golden Age, they might be able to launch something that people can use.
Or maybe somebody from you could, like from the audience, could do it, honestly.
Yeah, I mean, whoever sort of gets to that, thing first is potentially like that's quite an interesting sort of incentive there, because if you think about it, like let's just like run through the characteristics. So we're going to be offering like a 25% APY on the tokens. And there's like a curve. So it's like 3, 6, 12, but this is all subject to change, but like right now there's like a 3, 6, 12 month curve, and like the 12 month is like a 25% sort of APY. So what will happen here is you can only get that return by locking up mining rewards. I can't come in with stake and like just staking at 25%. So what happens is there's this big incentive to then take locked mining rewards and hypothecate stakeable assets. So then you'll end up getting you'll be able to come in with capital, buy this sort of liquid staked thing, and you'll get a return. Now, if miners if there's sort of like more supply than there is demand for rate of return, but miners are willing to like lock their tokens, say over just a year for simplicity, they'll effectively be getting like this sort of 25% bump in their profits just by holding it for a year. Now, if there's demand for this from the capital side of the world, what'll end up happening is someone's going to create this liquid mining scheme, and basically like the profits are going to end up getting split between the stakers and the miners depending on the balance of supply and demand. So if let's just say it's sort of in the mid case example, the expectation would be that if a miner locks tokens for a year and there's sufficient capital demand, maybe the miner makes 12% more in rewards by sort of selling that into this liquid stake protocol. And then the people that come in with capital, if they lock it up for a year, can make 12%, right? And then if sort of in the situation where there's a lot more capital than there's rewards, maybe the miners are making an extra 20% and the people staking are only making 5%. But that really depends on the balance between sort of like miner preference and like capital preference in terms of like how that sort of like APY gets split. If there's very little capital in the system, right, miners maybe only make 1% extra or 0% extra sort of instantaneously. So they're sort of committed to the full year when they lock it up, and they may or may not want to do that. But then that means that the capital could make, say, 24%, right? But it's sort of like a market determined outcome once you have sort of this liquid mine concept of how those profits are split between like the miners and what you would classically think of as a staker.
Mm-hmm. So just while we are on there, would a liquid swap be possible, or maybe it's already being built?
Yeah, well, so like once somebody makes this, these are going to look, depending on how they construct it, they're either going to look like an ERC20 or a 721. Right. So if you made specific sort of contracts with duration, it would look like a 721. If you created like a pool that's sort of like a perpetual, it would look like an ERC20 sort of thing. But it depends kind of like how people want to design the pools and like those products. Yeah.
Mm-hmm. Yeah, that makes sense. Then Kishore also wanted to clarify something that requires that in the dev server, we don't use the broadcasted topic as an input for the adjust peer quality. So the first time a peer broadcasts to us, peer won't be available on any of the peer sorry, I don't know how to pronounce that.
Peer DBs.
And we never databases. Okay. And we never add a new peer to the database as a result. So how do we add peers to the database, I guess, in the first place?
We don't use the broadcast topic as an input. So the first time a peer broadcasts to us, peers won't be available on any of the peer DBs. When was this from? I think this was like an issue we were having with the peer quality, that like came up as a bug that we've subsequently resolved. Yeah.
Maybe we can just talk about the general process of how we improved from the Iron Age, how there were some peering issues before then, and now we are resolving those in Golden Age. If you could just talk about that.
Yeah, so with these systems, there's kind of this like tension that exists between partitioning and dealing with network noise. And maybe it's a triangle, I don't know. And there's also sort of like CPU and bandwidth associated, so there's like processing. But from like a partitioning perspective, the way that I can be the most robust is to just always rebroadcast every transaction that like ever exists in the network. But then one person can come in and sort of create messages that flood the network, and then because we're under a limited bandwidth and processing constraint, like the network can't handle it. So then what we do is we say, okay, well, we need to come up with a ranking system for messages, so that we know when sort of a message meets a criteria to propagate in the network, and potentially a ranking system for peers, such that if peers are continuously broadcasting things that are bad, we sort of stop listening to them. Um, so that's kind of like the overarching problem. So in Iron Age, we sort of came up with this concept of a validator, which basically looks at a block, measures it, and then has sort of criteria for repropagation. So if somebody's doing something like, say, mining while sinking, and they're mining like very stale blocks from that like aren't anywhere near the tip, and they have sort of low value, those don't get re-propagated in the network. That's kind of the purpose of the validator. And then the purpose of peer ranking is if we have a peer who's continuously broadcasting stuff that shouldn't be broadcast, we sort of derank that peer. Or if a peer sort of, every time I ask the peer for something, they don't have it, we derank that peer. Or if I ask them for something and they don't respond, I derank that peer. Now, peers, I'll still randomly like ask them over time. So if someone goes from effectively being stale to being up to date, when they're stale, they'll have a bad ranking. But as they become up to date, and I randomly keep sort of querying sets of peers, their ranking can improve until they become like a good, lively, well-connected peer. Right, and that's sort of the purpose of peer ranking. And then there's one other feature that we have, that's called flow control, which is basically if I have like a set of peers, as peers sort of start overloading me, or a specific peer starts overloading me, like I kind of stop responding, or I stop fully servicing their request. Maybe I'll just act like I'm busy or I don't have that, which technically injures my peer ranking, but it makes it so that I'm always sort of lively for the people that I can, sort of deal with. Now, if it's sort of one peer that's sort of over asking questions, um, I use flow control to sort of throttle how often I respond to that peer specifically. So there's kind of like three layers to the onion in terms of how we deal with data, propagating in the network, and creating bandwidth requirements and processing requirements, validation, peer ranking, and flow control.
Yeah, I think that sounds very robust anyway. I cannot like speak to that myself because I'm not a developer, but I think we have one last like time for one last question from Kishore, and that is about external transactions. So external transactions can be transactions generated by the EVM or a Coinbase TX or a conversion TX.
Um, External transactions can be transactions. Yeah, so we've gone through different like classifications of, types, and it made the most sense because of, a number of reasons, specifically with Coinbases and, um, conversions, to make them an external type. They're an external type that re-references their origin, and so they're different than an external type. It's kind of like an internal external type, if you will. But the reason that was nice to do is it allows us to put locks on the system. So the conversions need a lock and the Coinbases need a lock. So sort of classifying them as a sort of internal external transaction like allows us to do sort of this locking behavior, in a in a nice, way, sort of programmatically. So that's why like Coinbases and, conversions are, quote unquote external. They're external, but they're coming back to the same, context. So a conversion is like switching ledgers, but it's not switching context. So if you think about it from like an address encoding scheme, the first 2 bytes are equal, but the seventh or ninth bit is not equal. That's like a conversion transaction, and then a Coinbase transaction kind of has a flag on it that says this is a Coinbase transaction. But they're typed as external types because the external types allow us to put that locking mechanism on there.
I think that explains it. Kishore also said that he got it. Just like to finish it up, external transactions do not have signatures, right?
Um, so for a conversion transaction, you still have a sig, right? For
Mm-hmm.
Coinbase, it's like a special type. Um, uh, I don't want to speak specifically on how we use SIGs or not SIGs in Coinbases because like we changed this recently and I don't have uh, up to date information on it, so I'll just forego that one for the moment.
Yeah,
Um,
Kiefer was mostly interested in the Coinbase ones, anyways, so that's all good. And I think we're just coming up on time, anyways. So, thank you very much, Dr. K, for your time, and thank you everybody for asking your great questions. I think some of them were very useful to get more insight. As we get further controller versions, I'm sure we'll have more to tell and maybe more articles to release. Thank you. Dr. K, do you have any last words before I close it?
yeah, no, it's getting exciting, getting ready for golden age. If anybody knows miners, let's get mining. If there's any guys that are good at sort of social influence on the Twitters, we've like started a new program. It's pretty selective. But if you ask the moderators about QUAI Rangers and you think you would qualify as a articulate,
It is still in development though, so it is very niche right now. We're just testing, just to clarify before.
yeah, it's very niche. But like if you think you would be good at helping spread the word of QUAI in a good way, um, reach out to a moderator.
Yeah, or me.
Yeah, or
Okay,
Veronica. Yeah. Cool guys. Appreciate everyone coming. Looking forward to next week. Get all your miner buddies, get their GPUs ready. I think docs are up now for mining. So people can kind of start trying to spin up and run nodes. But yeah, let's get this thing to mainnet.
perfect. Thank you very much, and bye bye.
Thanks, guys.